Good morning, my dear friends. Today I am going to explain mathematical induction. I have skipped this question in my previous videos. This is question 8 of October-November 2015's IB DP's paper. Right? Let's begin. Question states, show that sine theta plus pi over 2 is equal to cos theta. It's simple question, right? And we can do this question simply by using compound angle identity. Compound angle identity means sine theta plus pi over 2 is equal to sine theta cos pi over 2 plus cos theta sine pi over 2. And so cos pi over 2 basically 0. So sine theta 0 plus cos theta sine theta pi over 2 is 1. So this way you get cos theta. This was very simple, but you will need this application for the next part of this question. Okay? It's basic identity which we use to prove it that this is equal to this. That's it. Now I'm going to remove it because I want to explain my second part, which is the most demanding question from your side. Let's begin. He said f n x is equal to a n sine ax plus n pi over, where n belongs to z positive. Z positive means positive integers starting from 1 to onward, right? And he also explained fn represents nth derivative of this function fx. If you take nth derivative of this function, you will have this type of the formula. This is the generalized form of the derivative of this. Either you take 1 time, 2 time or 3 time, whatever the value of n, you can get the derivative of this in this form. Okay? Mathematical induction means you have no direct proof. You used 3 steps and then induce from previous results that this would be true for all values. So first case, generally we take the initial value in the given domain, and the given domain is any positive integer. So first positive integer is 1. So this way, if you have this function and fx is equal to sine ax, right? Its first derivative. 1 means first derivative of this. The first derivative of this would be a cos ax. But you have to give your answer. This derivative, first derivative, in this form, in this generalized form. You already have proved in the above part, in the first part of this question, that a cos, if we write sine ax plus pi over 2, cos ax and sine ax plus pi over 2 are equal to a. I mean sine ax plus pi over 2 is equal to cos ax. That's what we have already proved in the first part of this question, in this part. So this form, this derivative, first derivative of fx, this one, so can be written f1x is equal to a sine ax plus pi over 2. And you can now see this and this absolutely same. So this way you proved that your this formula which he has given you to prove that this is true by mathematical induction. So basically to prove mathematical induction we need three statements. Three statements are called propositions. Propositions are those statements which you prove either true or false. So my first proposition in which I took n is equal to 1 proved that this proposition is true for n is equal to 1. Okay? Then I assume that this statement, this proposition is also true for n is equal to k. So I am going to erase this part because I have proved and I think you have understood it well. Now my second, this was P1 and this is my P2 in which I am saying that this statement, this proposition is true for n is equal to k. For the proposition in which I suppose n is equal to k, I assume that this is true. So this statement f kth derivative is become ak sine ax plus k over 2 pi. That's it. Okay. Now I take the derivative of this. By taking the derivative of this function, in let's say I'm writing this, and then d by dx on both sides, right? By taking the derivative of f kth derivative, it becomes k plus 1, and then the derivative of this would become ak, because this is constant and you can write it in the beginning, and the derivative of this would be cos ax plus k over 2, and the derivative of ax is a. Then for the simplification, k, as you know, there is also k pi. Okay. Now this if there is cos, this is the identity for cos, and if I write sine ax plus pi over 2 k pi over 2, and then if I add pi over 2 90-degree angle to this cos, then this becomes equal to sine, which you already have proved there. So I just replace this cos by adding pi over 2 in that angle, whatever the angle is here, you have added it pi over 2 by yourself. By adding pi over 2 in this form, this becomes sine. So in the next step, ak, and this there is also k, a, sorry. So this becomes k plus 1, and then ax, and this becomes k plus 1 over 2 pi. So in next step, a k plus 1 sine ax plus k plus 1 pi over 2, and if you match it with this, you have assumed by yourself that this is true for k. I have written there f raised k, kth derivative is equal to a k times sine ax plus k over 2. When I have taken one more derivative of this kth, the number of derivative becomes k plus 1, and I also need to take the derivative on the other side, and the new derivative of this becomes this. I have shown the number of steps in a very simple way. So you see, this is f k plus 1. K plus 1 means this is k plus 1th derivative of this, and this is exactly same. Look, now the derivative is k plus 1, so a's power is k plus 1, and there is n, and now you have taken k plus 1, so there you proved that this is k plus 1 pi over 2, and this way you proved that the statement, the proposition that n is equal to k plus 1 is true for this generalized proposition or for statement which he has given you to prove. So I have proved 3 axioms of mathematical induction by taking first initial value in the given domain, then I took and assumed that this is true for any kth value, and then from there I used one more term, means k plus 1th term. So in all the results it is true. So my dear, this way actually we prove the question of mathematical induction, and this is same rule is applied in all questions of mathematical inductions. So I will, if you have still more confusions about this, it all depends on your comments and queries. If you say, I will give one more question or more exercise on that topic. Yes.